Yeah, there we go. Welcome to Malware Hunting with the Sysinternals tools. My name is Mark Rasinovich, and for the next hour and 15 minutes or so, I'm going to take you on a journey through the wonderful, delightful world of malware infestations, how to analyze them and how to clean them. And just actually, let me get a show of hands here. How many people have encountered malware before? Just, wow. How many of you have cleaned malware off of your family member's PC? Wow. How many people have, so this is all old news to you then, isn't it? How many people have cleaned malware off your own PC? How many people are here because you have malware on your PC right now? Anybody? Yeah. Okay, I'll clean it if we can look at your browser history in front of the audience. They never take me up on that for some reason. Well, the reason that we're here is because of this quotation right here, and you run into these kinds of quotations all the time. This is from a Google paper, actually, where their researchers have developed heuristics to go trawling the web and finding potentially malicious pieces of code. And what they found is when they concretely identified malicious code, they fed it into a whole bunch of antivirus engines. At the time they discovered the malware, and less than 40% of the AV engines detected them as malware. So this is what we call zero-day malware, malware where the antivirus engine does not have signatures for it. And the whole problem with that is that as a blacklisting kind of science that anti-malware is, the anti-malware is just not going to know about it unless the anti-malware's vendors or customers have gotten infected with it to the extent that the anti-malware security researchers have decided to go and figure out how to identify it and to create signatures and then roll them out, and they've gotten rolled out to the system. So there's long windows of time and even cases of malware where there's just not going to be signatures for it. So it's highly likely at some point when you run into malware that antivirus is not going to be able to help you. And that's the whole motivation for this talk. This talk is to teach you about some of the tools that you can use to go and both analyze and clean malware, as well as some of the techniques to go along with using those tools to do it. And the reasons to analyze malware are to understand the impact of malware. If you discover a piece of malware on your network, a corporate network, for example, versus a home, you want to analyze it to understand what that malware is, what it's doing, how it's behaving. Is it exfiltrating data? Is it just a piece of junk malware? Is it a botnet? Because that can determine how you respond to the malware. If it's something targeted at your corporation, you're going to take different steps than if it's just a random botnet client sitting there doing random things for whoever happens to rent it out. It also, in security researchers, this is kind of flattering for me when I go read security research documentation on how they went and analyze malware. A lot of times they use the Sysinternals tools as part of that analysis. And it's not just that they only use the Sysinternals tools. In fact, security researchers go way deeper, use way more tools, use debuggers, use disassemblers to go and figure out what malware is doing. But Sysinternals tools a lot of times gives you a kind of high-level view of the way the malware is operating, and can oftentimes, just with that high-level view, give you a roadmap for cleaning the malware off the system. So understanding the impact, what registry keys is the malware modifying, what files is it dropping? Those are some of the things that you can answer. And then, of course, once you've figured out where the malware is and how it's operating, then that's kind of the key to being able to clean it off the system. Where has it injected itself into the registry? Well, bam, let's go zap it out from there. Where's this file? Let's go kill it. And so that's what I'm going to spend time talking about. Now, speaking of anti-malware, there's this anti-malware here. It's called Sysinternals Antivirus. How many people have used this before? And actually, this is a case where I'm not disappointed that you're not using a Sysinternals tool, because this is actually, well, I didn't write it, so it's really not a Sysinternals tool. It's actually not very good because it's actually malware. And what really pisses me off is that they don't even link to sysinternals.com in it. So they take the brand and they don't help promote it, which is really annoying to me. This recipe right here is a recipe that I came up with back in around 2005 when I started to teach this kind of session on cleaning malware. And in fact, this recipe is the same recipe, still holds valid today. Kind of the steps that you'll follow once you find a machine that you suspect is infected with malware, because it all starts with, I suspect the system's infected with malware. This is one of the kind of key principles. People come to me and they say, Mark, can you look at my system and tell me if it's infected with malware? The answer is no, because I don't know what to look for. If you tell me a symptom, then I can start to dig in to what's causing that symptom and then figure out if that's malicious or not. So this kind of process, this recipe, always starts with machines doing something. It's talking out to the internet some weird way. It's churning my disk activity. It's a process that I don't recognize. First steps in this recipe, disconnect from the network. And the reason that I put this in the first place is back in 2004, 2005 time frame, malware operated a little bit differently than it does today. Malware back then was scareware, adware kind of host engines. So what they would do is get on your box and then go pull crap down, more malware, for whoever wanted to pay to deploy to your machine. And they would do it really aggressively. So this is when you had systems that would take half an hour to boot because there was so much junk, malware, adware, spyware sitting in the systems. And I would actually start to clean those machines, and while I was cleaning them, they'd be pulling down more malware. So the only way I could get ahead of the game was disconnect from the network. So that's kind of one of the reasons. Another reason to disconnect from the network is if this is a piece of malware that's exfiltrating data from your network, we'll stop it from exfiltrating data. But it does come with some negative implications. There are some things that you might not be able to understand about what the malware is doing unless the malware can go talk to its command and control server, and you won't see that. And it also has implications on you determining whether a piece of code is legitimate or not that I'll talk about a little bit later. So this has pros and cons. Next step is kind of reconnaissance. Look at your system and try to identify suspicious-looking processes. It's not necessarily identifying at this point ones that you think or you know are bad or sure are bad. This is just, let me take a look. These things look legitimate. They're familiar. I know what they are. These I don't really understand, and we're going to dig a little bit further. Once you have identified the suspicious ones and you've researched them a bit and concluded that they are likely malicious, the next step is to terminate them. And you do this step before you go into cleaning because a lot of malware has self-defense mechanisms that I'll talk about that make it difficult to clean them when they're active. So get them out of the way, and now your next step is to go make sure they don't come back. And every piece of malware has some way of getting back and active after the machine reboots or after you log off and log back on. You need to figure out how it's doing that and go take care of that part of it. And then to be extra thorough, delete the files that you've identified. Don't just delete the activation points, but delete the files that are being activated. The reason that I do this is, well, it just cleans the crap off your machine, but also you might not necessarily have caught all the components of the malware. And by deleting the files that you know of, you might actually be breaking the malware. So if you left them there, they might reactivate in some way you didn't anticipate. By deleting them, you might have just ripped the malware in half and killed it. And then, just like any good shampoo, you want to lather, rinse, and repeat because you might not have gotten everything. So go back to the first step, see if there's symptoms or persist, and go back and look for suspicious processes and DLLs and kind of the same steps again to make sure that you got everything. Quick note here about philosophies of malware and what I just talked about, because what I just talked about is analyzing a system all the way through to cleaning it. And there's people security people, very security conscious, people that will say never clean the malware, flatten the system, and start over. And I'm actually a pragmatist, and I know that customers, the ones that Microsoft deals with, also are pragmatists about this. It's a matter of risk. Everything in security is a matter of risk management. If I'm confident that I have identified the malware, the source of the symptoms, if I'm confident that I'm able to clean off, then I might take that route rather than the likely very, very expensive route of flattening a system and moving on. We've got customers. In fact, there was a large EU organization a couple years ago that their domain controllers got infected with malware, and they called in Microsoft Consulting Services, said, take a look at this. MCS analyzed the systems, got a high degree of confidence that they understood what the malware was doing, and said, we think we can clean it, but your call, we'd recommend flattening your domain. And what do you think the EU organization did? Flatten their domain or have MCS clean it? Clean it, right. How many people have run into malware on a domain controller? Anybody? And what have you done? Have you cleaned it or flattened? Clean. Anybody flatten a domain when you've run into malware on a domain controller? See, that's kind of the trade-off that we deal with, and that's why these steps are here. Especially if it's your mom's computer and you say, Mom, I'm going to flatten your computer and all your stuff's going to be gone and you've got to reinstall everything. And that doesn't normally, or your wife especially, that doesn't end well. All right, let's talk about identifying malware now. These are the characteristics that I came up with, again, back in 2005. Processes, the attributes they exhibit that make them look suspicious and that merit further research. Any process that doesn't have an icon, it's kind of generic icon, no icon, doesn't have a description or company name in its version information, because most legitimate software advertises what its purpose is and who it's from. It says that it's from Microsoft, but it doesn't have a valid Microsoft digital signature on it. It lives in the Windows directory of the user profile, as opposed to the standard places where software gets installed, like program files. And this one is more and more now malware living in user profiles, as you'll see. They're packed or encrypted or compressed. I'll talk more about that in a little bit and how you identify that. They've got URLs in their strings that are pointing off at strange places, like places in Morocco or China or Ukraine. Other places that I'm sure nobody in here is from, so I can't offend you, right? Anybody here from Russia? Okay, so Russia is a fine place to have strings. They also have suspicious DLLs or services. So how many people use Task Manager to go about cleaning malware? Let's see, raise your hands. So that's embarrassing. I can't believe you raised your hand. Actually, the tool we're going to use is not Task Manager, because Task Manager is kind of like walking into a room blindfolded and fumbling around. It just doesn't show you a lot of information. Certainly, if you look at this list of characteristics, Task Manager is not going to help you with a bunch of them. So the tool we're going to use is Sysinternals Process Explorer. How many people have used Process Explorer? So that's good to see. Nice raise of hands. Process Explorer, some people call it Super Task Manager, and it's actually a tool that I started developing about 15 years ago and have been adding to ever since, aimed primarily at troubleshooting. In fact, I'm giving a session right after this on troubleshooting. But it's good at finding locked handles to files, at DLL conflicts, sluggish performance issues. What I'm going to do in this session is focus just on Process Explorer's malware cleaning capabilities. And let's pull up Process Explorer and take a look at some of the things you'll see. I've got it here running in the system tray. When I pull it up, the first thing you'll notice is that it organizes the processes as a process tree, something you don't see even in the newer versions of Task Manager. The process tree can help you understand the relationship between processes. This is very important when it comes to looking at suspicious processes and determining if they're malicious or not, or related to a process that you've identified as malicious. If you know a process is malicious and it's got a child, well, you automatically know that child is involved with maliciousness as well. Let me give you an example of how you can see the process tree in action. Everything under the services process, which is the Service and Control Manager application, is hosting a Windows service. So we know just by the parent-child relationship that the children of that process are Windows services. Correspondingly, everything under Explorer, which is my shell, which is the default shell, is going to be launched as part of my logon session. It kicked it off. So every process that I've launched since I logged into Windows is going to be a child of Explorer. You also see the description and company names. So I can see, for example, that this Explorer is Windows Explorer and it's from Microsoft Corporation. I'm not even going to talk about the various performance counters because that's not relevant for what we're talking about here. But another aspect of this process view is being able to find which process owns a window. If you've ever had a case where there's a suspicious window and you want to know which process owns it, let me just create a suspicious window here, Notepad. I want to know who owns Notepad, which process, and pretend this is something that's doing something suspicious. Well, Process Explorer will take me and select the process that owns that window, which can be useful for cases where you get pop-ups that say, yeah, your system's infected with malware and it's a piece of scareware. Well, what process is popping up that dialog will be answered with that window finder right there. Process Explorer also has a search online capability. When you right-click on a process, like Explorer, you can select Search Online, and this will take you to the search engine of your choice. And let me make sure. See, so yeah. So this is a good way to look up a process that you might not know something about. Now, the reason I'm not actually going to focus much on that is because almost all malware these days uses pseudo-random or completely random names. And the random names, obviously, you're not going to run into the same random name twice on two different systems, so it's unlikely you're going to find anything in a search hit. The pseudo-random names are really cool. I haven't seen them in a while, but what used to be very common for malware to take chunks of legitimate files or directory names and concatenate them together, and just like developers do when they name their crap by just taking words and concatenating them together in weird ways, it just sounds legitimate when you do that. So it's a great way to make pseudo-realistic names just by taking pieces off the system. Let's talk about refresh highlighting. Refresh highlighting will tell you when processes are coming and going. So when I launched that notepad, you might have noticed that a green bar showed up there, and I've got the refresh highlight duration on for 9 seconds, so that will remain green for 9 seconds. And then if I delete a process, it'll turn red to show me that that process no longer exists. So this is one way that it's very easy to see processes coming and going in Process Explorer, that hard to see in Task Manager. The problem with this, though, if the malware is noisy, can be very useful. But for processes or for very short-lived commands, let me see if I can get, ipconfig used to be really fast, but it's gotten really slow now that it's got so much crap. Oh, but there, you see I just ran an ipconfig and no green process showed up. That's because it ran between Process Explorer's refresh intervals, so Process Explorer didn't even see it exist. So we don't see it show up here. I'm going to talk a little bit later about how you can find processes that are short-lived. Then there's process highlights. Take a quick look at those. There's pink processes that you see here. Anybody know what pink is? It's a girl process, obviously. No, I'm just kidding. It's not a girl process. These are processes that are hosting Windows services. So I mentioned that everything under Service Control Manager is a Windows service. You can see as I collapse these are all Windows services. There's a few exceptions, but for the most part, all of these pink are definitely Windows services, and almost all of them, almost every process under Services Control Manager is hosting a Windows service. The blue processes are ones running in the same security context as Process Explorer. Cyan here means that it's an immersive or modern or retro or whatever kind of cool word you want to use kind of app. So it knows how to run on the start screen as well as the desktop. Explorer is an example of that kind of process. And then we've got white, which means no filter applies, no color highlight applies, running in some other security context, isn't hosting a Windows service. You see some purple ones, which I'll talk about here in a second. Purple means that it's packed or encrypted according to heuristics that I've built into Process Explorer. And a lot of malware uses encryption and packing techniques to try to obfuscate it from antivirus. The way that they work is they take their body, their executable code, they compress and encrypt it, and then they've got a stub that knows how to unroll that into memory and then launch and then jump into it. So when anti-malware looks at it on disk, it doesn't know what it is. And what anti-malware has these days is basically virtual machines in them that try to emulate Windows, if they're on Windows, and they will go and unpack, basically start executing that stub and let the thing unpack into memory and then go look at it and see if it's a piece of malicious code. But the purple color, you can see I've got two processes that are highlighted in purple, indicating that they are likely packed. We'll come back to that shortly. The tooltips will show you information about what's hosted inside of a process, if it's a hosting process, and Service Host is one that you're probably familiar with. Service Host hosts Windows services, multiple, they can hold multiple. They're loaded as DLLs into the service hosting process, and you can see the list of them that are loaded into this particular service host just by hovering over this. Malware sometimes buries itself inside of a hosting process. One type of hosting process that's very common is run DLL32, which I can create one of those here. Let me see who owns that process. It's this run DLL32 down here at the bottom, and if we zoom in, the tooltip tells us that it's the time date .cpl DLL that's being hosted inside of that. So, and run DLL32 is also a very common place for malware to hide because it shows up in Task Manager, blends in with everything else. It's a Microsoft executable, so be sure to take a look at those tooltips to see if there's anything fishy. Some new things that I've added recently in Process Explorer: auto start locations, which I'll come back to, and process timelines. These are process timelines you can add as a column, and they will show you the lifetime of the processes. So if you want to know, is this thing short-lived? How long has it been around? Did it start when the system booted? You want to get a graphical representation, you can add that. And then auto starts I'll talk about in a little bit. When you double click, you can see detailed process information. So let me pull up Explorer, and you can see, for example, the path to the executable, the command line, the current directory. I mentioned the auto start location. Because Explorer is the default shell as programmed in that registry key right there, that's why Explorer launched when I logged into the machine. Other things that are useful: the start time. That can tell you if this thing, hey, did it start last night or has it been around for a while? Did it start when the suspicious activity started? And here's some executable code. Does it have ASLR in depth? That's really not related to malware. The build time. If it's got a build time that is suspicious, maybe it's really old, or maybe it's extremely new, that can be a clue if it's legitimate or malicious. There's some other tabs that we're going to take a look at. TCP/IP open endpoints. So if the process, pull that back up, might have network endpoints open, you can see that easily by going to the TCP/IP tab. So here is an example of a process that has a number of UDP TCP endpoints open. These are services. You can see the crypt service and the DNS caching service are owning those endpoints. So if you see a suspicious process, take a look to see if it's got anything active as far as TCP/IP connections. Now, most Microsoft software is digitally signed, and so when you come across a process that's suspicious, especially if it says it's digitally signed, or even a process that isn't from Microsoft, check for a digital signature. The lack of a digital signature these days does make a process more suspicious because almost all legitimate software now is digitally signed. That was changes kind of forced with Windows Vista and UAC. We got the ecosystem in the habit of digitally signing their software. I've got a suspicious process that we've already seen, this one that looks like it's packed. It's called WinHost, and if you take a look at its properties, it's sitting in the Windows System 32 directory. Well, that's not terribly suspicious in the case of something called WinHost because that looks like it's part of Windows. As far as its description and company name, that's also not terribly suspicious. It says that it's from Microsoft, which we'd expect of a Windows executable, and it actually says it's the Windows Host Support Services process. What makes this suspicious at this point is only the fact that it's packed. It's got the packed highlight color, which says Process Explorer thinks this thing is compressed or encrypted. So we want to take a deeper look at this thing to see if we can find any more clues to more conclusively say, is it malicious or not malicious? One of the things we do is check to see if it's got a digital signature that says it really is from Microsoft. If we go back to the Image tab, you see here it also says image is probably packed. There's a button down here called Verify. When I press that button, Process Explorer will try to verify the digital signature on that executable. And you see in this case, it says no signature was present in the subject, which means this does not have a valid digital signature. It really isn't from Microsoft, apparently, because if we take a look at, for example, explorer.exe, which we know is legitimate, and do a verify on it, we'll see it says verified in that case. So now this thing is even more suspicious that it's not digitally signed from Microsoft, though it says it is. But we'll still want to get some more clues. Now, when I am going and somebody tells me they got a machine infected with malware, I do not just go one-off by one-off and check digital signatures. I do a couple things. One is I have Process Explorer check digital signatures on all the files, all the processes, by going to the process image column and saying add the verified signer column to the display, and then going to options and saying verify image signatures. At this point, Process Explorer is going to go and check the signatures on every executable of every active process. And then I'll sort, and down here at the bottom, I'll see just the processes that don't have signatures. So here's one. Actually, I'm using some screen grabbing tool. It looks like they didn't sign this particular binary. I've got test versions of Sysinternals, which I expect not to be signed, and then these two, which are the suspicious DLLs we just looked at, or executables we just looked at. So that's what I will do. I also will use a command line tool called SIGCheck. SIGCheck-E, which says check all executable images, including ones that don't look like executables. Like if it had a .html extension on it, but it was executable, this command will still have it check its digital signature. And then I'll say only show me the unsigned ones, -U, and then I'll say, typically I'll go to the root of the system and do -S to look for everything. I'll just shortcut that and just look at my Windows directory, and you can see that the only one that it found is that process that we have been looking at there as the one suspicious executable sitting in my Windows directory. Everything else is digitally signed. There's also a way to scan the DLLs of running processes, and I'll talk about DLLs in a minute. Now, this WinHost looks very suspicious. We need to take a deeper look inside of it. Well, let's take a look at its strings to see if there's any suspicious strings in it. There's a tool from Sysinternals called strings, and I could run that on WinHost. But the problem with WinHost and most malware is that it's packed. In fact, you can see that the way that this is packed is using a common packer called UPX, which a lot of malware uses, which means that I'm not going to find strings in here because they're all encrypted or compressed. This is just the version information at the end of the file here. So strings is not that useful. Instead, what we're going to do is turn to Process Explorer and take a look at the strings that way. If I go to the Strings tab, now this will show me the strings in the image, which is just what we saw with strings. I'm going to click on memory to see what's decrypted in memory. And now what I'm going to do is look for suspicious URLs, for example. And yeah, this one seems to be even more conclusively a piece of malware. It's got a suspicious URL in it. And so we've just confirmed that this thing is following our signs of malware and something that we should go and clean off the machine. The DLL view is something you should also look at, especially for those suspicious DLL processes. When I do a Control-D or open the lower pane into DLL view, I see the list of loaded modules, including the executable in the process. Same things apply here as far as the verified signer column. You can see that Process Explorer is gone because I set that option. And I added the column showing me the signing status of all the DLLs that are in that process. And I can see the WinHost stick out like a sore thumb even in the DLL view. And I would do that also for those hosting processes like run DLL32. Take a look at its DLL view to look at the DLLs that it's hosting to see if there's anything suspicious. Next thing we do now, if we finished our reconnaissance, is terminate the running processes. But terminating them, killing them outright is a little bit cold. So what I recommend, just a little more humane, is put them to sleep first and then kill them. And that way they don't know what's happened. It's just a nice way to die, a nice peaceful death, instead of a very abrupt one that they would get just with a bam, you're dead. Now actually, I'm not that humane when it comes to malware. I do just like whatever, it's malware, let's kill it. But watch what happens when I try to kill this WinHost. See what happened? I've got another one down here. So I got to try to whack that one. Well, another one popped up. What's going on here is that this thing is the buddy system. One guy, there's two of them, one is watching the other one, so when I try to kill one, the other one revives him, reincarnates him, and so that there's always two buddies watching each other's back. And the way to deal with that is simply to suspend them. They'll show up in dark gray, and now at this point, bam, and bam, and now I've terminated them. So now they're out of the way. Next step, cleaning them out, auto starts. How many people use msconfig to clean auto starts off your machine? So that's also, I can't believe you're raising your hand, especially after I made fun of all the task manager people, because it's not much better. Although I will say, there's been a heavy investment in msconfig in Windows 8. Let's take a look. So we go to the Startup tab, which is where we're going to be looking for these startup. And see, look at that. That's just real commitment to excellence on msconfig. Actually, Task Manager kind of has an auto starts thing going for it too, but it's Task Manager. So we're going to use auto runs instead. How many people have used auto runs? Good to see. Now let me fire up auto runs on my system. Take a quick tour. And auto runs shows us a list of hundreds of places where malware or legitimate executables can be configured to start on boot or log on. They're organized with these blue bars. So here's the run key, for example. And for each one of these things, we see the same kinds of things we saw in Process Explorer. The name of the entry, the description, the company name, and the path to the executable. Down here at the bottom, we'll see the timestamp for it, version information, and size. We can also do the right-click thing and jump to either the entry, which is the place in the registry where the thing is configured, or the file system. Or you can do jump to image, which will take us to that image of HK command. So I do jump to image, and it'll open an Explorer window here and take me to HK command. I also can do the search thing, take a look at the properties in Explorer. And but this list is overwhelming. In fact, what I've done is turned off the default filtering. Here's the filter dialog. And when I'm looking for malware, I check verify code signatures, hide Microsoft entries, which also hides Windows entries. And that lets me focus just on third-party software, including software that's been signed. Anything that's unsigned shows up in red. So these are the Sysinternals tools that I've been working on. 7-zip is unsigned. But you can see that everything else is generally signed except for this WinHost. Again, stands out like a sore thumb. And it's sitting in a place in the registry that Task Manager and msconfig don't look. Current version policies Explorer run. And at this point now, I'm ready to deal with this. And the way that I'll do that is by unchecking it. And I've just disabled it just like an msconfig. Never delete. Number one golden rule of troubleshooting, try to make everything you do undoable. And so if I deleted it and it was something that like deleting it made my system unbootable, I could very easily put it back by going into offline mode and dealing with it. And speaking of offline mode, some things to be aware of, but I don't have time to cover with demos, are that AutoRuns knows how to look at other profiles on the system. So if you've got somebody that's a standard user that's infected, you can log in with an admin account, point AutoRuns at their profile. You can see there's the profile menu, and scan their account for malicious software. You can also use it in offline mode. So you can boot from WinPE or Windows to Go, point it at an offline registry or offline Windows installation. It'll find the registry hives and do a scan that way. So you can clean even machines where the malware can't be dealt with while the system's active. I've added a feature, the last modified timestamp, very quickly to show you that. So you can see the time that the entry was modified. So this, again, correlating timestamps with malicious activity. If you see malicious activity started last night, and I've got a timestamp in an auto start location that corresponds to last night, then it's suspicious. That's another piece of correlating information. Now, tracing malware activity. This comes into play when you've got a piece of malware that you know how to reinfect a system with and you want to understand how it's operating, or you want to watch, you know that malware is actively messing with the system, you want to see what it's doing, or you just tried to clean the malware and it comes back. Like you deleted the file, you look again a few seconds later and the file's back. Where did it come from? That's where tracing activity comes into play. And for that, we're going to use Process Monitor. Process Monitor is great for troubleshooting, but it's also useful for this. And it's so useful for many things that Dave Solomon's come up with a slogan. Some of you, if you've attended my sessions before, have already said this with me, but let's all say it together. That's a slogan there at the bottom. Ready? 1, 2, 3. When in doubt, run Process Monitor. Now, I only heard these people right here. How about this half of the room? Ready? 1, 2, 3. When in doubt, run process monitor. All right, this half can definitely do better than that half. 1, 2, 3. When in doubt, run process monitor. Okay, no, maybe I was wrong about that. We'll get better as we go. Actually, if you come to my Case of the Unexplained, we're just going to go saying that all afternoon. So hopefully by the end, we'll all be good at it. Now, let me fire up process monitor very quickly, take you on a very quick tour of that. And then this is the last thing we're going to kind of do as basic education before we get into real malware cases. Process monitor shows you a list of all active process, thread, file, registry, and network activity in real time on the system. It's just buffering this. You can see it's already got 600,000 events that it's collected because there's a lot of stuff doing things in the background here. For each operation, you see a timestamp by default, the name of the process, and we see a tooltip which will show us the company name, description, and path. You'll see the process ID column, the operation, the path of the operation, if there's a registry key here, a file there, the result of the operation, and then the last column, detailed information depending on the operation type. So here's a reg query SZ, and the data that came back from the registry value was ntdevcorp.microsoft.com. Here's a file system IO, which is at offset 8 million in the file, 16K IO, and it's got non-cached IO set on it. That's the basics of the view. When you want to take a closer look at the event properties or the process that emitted the event, you'll double-click. The Event tab shows you all of the information that you can add as columns, but if in case you've messed with the columns, you can easily see that information here. And then the Process tab will show you something that looks very similar to what you saw in Process Explorer. So here's a service host, here's the version, here's the path, the command line, and you can see this is the net services service host, architecture virtualized, what account it's running in, and the DLLs loaded into it at the time of that particular operation. The last tab there is the Stack tab, which is useful, very useful for troubleshooting. It's not useful as useful for malware hunting. Occasionally it'll be useful, but I'm not going to focus on it in this session. A key to using Process Explorer effectively is filtering. And there's a few ways to filter. One way is to right-click on what you're interested in. Like I'm interested in the Microsoft Malware Engine. I can right-click and say, include just that. And now I've just got the Malware Engine running. I can say that I want to see just file mappings of the Malware Engine. I can say that I don't want to see that. I can say, don't show me any events before this, and filter out that. So you can narrow, don't show me any events after this. So you can use those quick filters to very quickly zoom in on some particular area of interest. You can always say Control-R to get back your full set of data. One of the things that I use, one of the features I use is for malware hunting to understand the impact of malware, and you'll see this in the demos when I've got real malware, is to set this category here, category is right, and say add. And what this does is now shows only operations that are modifications to the system. So modifications or attempted modifications to the file system. And let's just look at successes. So these are write files, registry set values, registry value sets. And so if we're looking at the impact of malware on the system, how it's putting things back, that case of that file that magically reappeared, this category is right. We'll automatically filter for just those kinds of things. And you'll see in the demos how useful that is at understanding malware's behavior. Then there's the process tree. Remember I talked about IP config and how short-lived processes, I didn't necessarily wasn't able to see everything in Process Explorer. Well, with the process tree and Process Monitor, short-lived processes, no matter how short, can't hide from the process tree. And this is the process tree. Now, I ran an IP config, and I know for a fact that it's going to be there. And you can see here in the process timeline, very short. And the process tree will show me, again, the same kinds of information, including the fact that command.exe was its parent process. as well as some information down here when it started and ended. So the process tree also makes it really easy to set a filter. I just set a filter just to include command.exe, ipconfig, and now I can zoom in on what it's doing. So that's a whirlwind tour of Process Monitor. Are you ready to do some real malware hunting now and not just mess with my toy WinHost, even though WinHost was pretty cool, you got to admit, wasn't it? Let's take a look at a real case. This case that I'm going to talk about is WinWebSec. It's a real piece of scareware, and this is from the latest Microsoft Security Intelligence report. You can see that this green line here is WinWebSec's prevalence out on Microsoft machines that you guys all run, where we get telemetry back from the malicious malware software removal tool, the cases of WinWebSec, second only at this point to this OneScan piece of malware. So very common piece of malware. By the way, in case you didn't miss this proverb up here, I found it on, somebody tweeted it one day, and it's just really funny. Give a man a stolen credit card and he'll eat like a king for a day. Teach a man to fish and he'll be set for life. Ancient Nigerian proverb. Nobody from Nigeria in here, right? Okay, good. Because you're likely a prince if you are, and got some money that I'd be willing to transfer for you into the United States if you'd like. So let's take a look at WinWebSec. I've got a virtual machine here ready to go with WinWebSec. Let's see what it does. And it takes a second to activate. Here it's just launched. And this is a piece of scareware. It's called scareware because it's like that Sysinternals antivirus. It looks like something legitimate, although in this case I'm running on Windows 7 and it's got the XP theme because they're tuned for the system that they probably expect to hit most often, which is Windows XP. Well, they'll blend in and look like a legitimate piece of code. But you can see it's like scanning away at my clean install virtual machine and just finding all sorts of crap in there. How many people have run into scareware like this? So quite a few of you. Let's see what kinds of scary things it's finding. So backdoor, netcfg. Oh, so okay, 23 infections. System crash, permanent data loss, system slowdown. Do I want to remove all the threats now? Or do I want, you know what? Hell with it. Continue unprotected, I don't care. Well, let's take a look at what its other things it found, because NSLOOKUP, if you've got NSLOOKUP on your machine, or ping, even worse. Ping is really scary. It's a dialer, apparently, which I wasn't aware of. Oh, and look, there's a new database of updates, which is kind of interesting because I'm not connected, and this machine hasn't been connected for a very long time. So yes, I want to continue unprotected. Now, the thing about this piece of software, by the way, is that it gets more and more aggressive as we go on. So if I delete this, it's going to get pissed off that I'm not buying into it. So the first thing it does is just say, hey, you're infected. You're really an idiot. You should pay me. And by the way, I'm going to stop you from doing anything here now at this point. So MS Paint's infected with Trojan Downloader. Do you want to register now? No, I didn't need to use MS Paint anyway. What's funny about this is config's infected with Spyware 132 help clear. Do you want to remove? No, I don't want to do that. But if I run it again, oh, now it's infected with Trojan Spy 132 ZTOB. This time, oh, it's infected with Networm. So whatever malware is on there, it's really pretty sophisticated, infecting the machine in lots of different ways at different times. Of course, if I gave in and I said, yes, I want to pay, it's going to take me to a place where I need to enter my credit card and clean the machine off. Now, if I rebooted this machine, the malware would be back. I mentioned that one of the things that we do is look for auto starts. And I already had auto runs running to see if this thing shows up in auto runs. The first time I ran this with this piece of malware, look, auto runs is finished. Well, it's still scanning, but it's going to be finishing here in a second. And it's not going to show anything suspicious. These are desktops and Zoom It Sysinternals tools. No suspicious auto runs. So now it's done. How does this thing reactivate? Because I rebooted the machine and it's back. Well, I'm going to come back to that in a second. Let's get the VM ready so I can show you. And in the meantime, I'm going to go to a real case that a customer, somebody submitted to me. And then I'll tell you how I figured out how it came back. So in this case, a user's friend complained that their system was infected with malware. And this is one of those cases where you might have run into it, where a friend you haven't talked to in a long time invites you over for dinner out of the blue one day. And you have dinner, and the guy seems to be in a rush to get through the dinner for some reason. And then, oh, now that we're done with dinner, we're waiting for the coffee to get ready. Can you step into my office? I've got something I'd like you to take a look at. And sits the guy down, and this is what he shows him. Looks familiar, doesn't it? 26 infections found. Your system's just a mess, and you can't do anything with it. So this friend's like, okay, here I go. Let me see if I can help you. So he tried running Process Explorer. Same kind of behavior we just saw. It's blocking the user from running anything. He tries to go to sysinternals.com. Can't even hit sysinternals.com. So at this point he said, well, if you can't go to sysinternals, this machine is completely useless. And so no, I'm just kidding. So, okay, so what did he do now? He booted into safe mode. Now, safe mode is a mode that up to Windows 8 used to be relatively easy to get to. In Windows 8, it's gotten a little more tricky to get to. How many people have gotten into safe mode in Windows 8? That's good, because you've just passed like a major IQ test on the way into safe mode in Windows 8. It's like 15 steps now to get into safe mode. Before it used to be just reboot, press F8, and boom, say safe mode. Now it's like go to general settings, PC settings, general, repair options, advanced, reboot the machine, select, no, I want more advanced, reboot the machine, say I want safe mode, reboot the machine, and now you're in safe mode. So I don't go into safe mode anymore because it's like clear that I'm unwelcome. Microsoft doesn't want me to go to safe mode anymore. What they want you to do is go to Windows to go, which is actually kind of useful. Windows to go instead of safe mode. Carry around your USB key, and now you're essentially always in kind of a permanent safe mode where you can debug offline. Any case, this guy goes to safe mode, and he runs Task Manager, or he runs msconfig, and look, he doesn't see anything. Sees Microsoft Security Client, which is legitimate, apparently. So he goes and fires up autoruns, and actually I have the autoruns file here, but I'll just show you right here. He sees this in the run once key. So this is how this thing is activating. It's a place that msconfig and Task Manager don't look, is run once. Actually, you won't see run once when the system's active, because the behavior of run once is a piece of software configures run once, the system reboots, Explorer runs whatever is there, and then deletes the key. So after the thing is active, the auto start location's gone. Let's see what happens with that WinWeb sec that we were taking a look at. Because I've booted this machine into safe mode. Well, actually, no. Actually, let me take that back. I didn't. You can see I didn't in this case. I've rebooted the machine, but to watch what happened during the shutdown of the machine, I try to move this out of the way. I ran Process Monitor, and I ran it in boot logging mode. In Process Monitor, if you go to the options and say boot log, shut down the machine, when you reboot, it captures everything that happens from the time of the very early in the boot, all the way, if you want it to the shutdown of the machine. It'll stop when you run Process Monitor again. If you reboot, it's boot logging, you run Process Monitor, it'll say, hey, do you want to save this log file that I've captured? What I did in this case is let it run all the way through to the shutdown and then reboot it again and ran Process Monitor. The reason that I could run it is this malware takes a few seconds to start to get aggressive and block things. So I was able to run it. And now that I've got auto runs, Process Monitor capturing WinWeb sec, which is the filter that I've already set to focus on the piece of malware, I go to the very end. Here's what it configured itself to be in the registry. Oops, let me do this kind of thing. This is the dropper that it created with the random name. And you can see this is on the very end of the system shutting down. It does a red set value and puts itself in the run once key. If I click right here, you can see there it is, dropping itself in the run once key. And that's why we didn't see it show up in auto runs when we had infected the machine. It was waiting there for the system to shut down and then infect the machine. Kind of interesting technique, which I anticipated coming. This kind of malware, though, is extremely vulnerable to BSODs. If this machine crashed before the shutdown, this thing would be gone. It would never activate again. If you terminated the process, so if I managed to get Process Explorer up and running and killed it, that would also have cleaned the malware off the machine. It would not be able to write its run once key on the way down, on its way exiting, and get active again. But to clean this machine, you do just what that user did, boot into safe mode, use the offline, use auto runs in that case. Always boot into safe mode with command prompt, not safe mode with networking, because safe mode with networking actually launches Explorer, which will launch the run once key. So you need to run safe mode with command prompt. Let's take a look at another example. This one demonstrates how much more aggressive malware is getting these days. And while this is applying, let me show you some screenshots of this new class of malware, or relatively new. It's been around actually for a while, but they're getting much more common. And by the way, I've got a bunch of samples of this kind of malware. It's called ransomware. Now, this piece of ransomware right here, as I was activating it, it had the gall to ask me to elevate it. You can see right here. Like, I want admin privileges. And this kind of shows you that malware, that most users will probably click OK just to get rid of this dialog. Like, I don't care. Like, this is some random Windows thing. I don't know the difference between an orange dialog and a blue dialog, and it's just UAC nonsense and just, yeah. And so the malware asks for admin rights and can get them. Now, it's OK if the malware doesn't get them. It'll just infect the system as standard user. But if it gets admin rights, that's when it just like blows away the antivirus and really establishes a strong foothold. So I was pretty impressed at the boldness of this guy. But here's what those things do after they activate the machine, is they take over the machine completely, like it's a kiosk mode thing, and with a scary message that says your machine is got bad stuff on it. And the only way to get rid of this bad stuff is to pay. So in this one, warning, your files have been decrypted. Actually, I think they meant encrypted. But we have detected spam advertises illegal sites with child pornography from your computer. And this actually is what gets people. And this is what we commonly see with ransomware, is you run into this, your average user using your PC, and you run into this, and it says you've got child porn on your computer. Like, are you going to want to take a chance getting law enforcement involved with this and being drugged through some process of proving that it's not really your child porn? And so what people will do is just say, oh, hell with it, I'm just going to pay and get my system unlocked rather than deal with the risks of dealing with law enforcement. Here's one from Germany. So they look like they're from official government agencies. This one is interesting. It's Russian, and it actually, instead of telling you got child porn, it wants you to buy something first. So these are, go buy the unlock code. Here's one from the FBI. And I didn't know the FBI used Money Pack and that you could get at Kmart. And here's one from the Department of Justice. The Department of Justice also uses Money Pack. I guess that's the official government way of paying for unlock codes to get your computer back. So that's an example. Now, I've got an active piece of this thing. This one right here. Let's see what this one does. So this is lock screen CT. And in a second here, there we go. It's taken over my machine. You can see, obviously I can't read this, but it's asking me to type in a pin, and I can't interact with anything. In fact, if I try to do like Control-Shift-Escape to launch Task Manager, it kills any process that it sees running on the current desktop. What I've done to highlight this is I have a Sysinternals tool called Desktops running on a separate desktop here. I've just Alt-2'd to the second desktop. Here's the Desktops utility down here. And actually, I can't click on it because this is kind of interesting. Let me show you this. I'm going to do Control Window M. And I'm going to drag the mouse from one side of the screen to the other. You can see it's got an input window. It's only letting mouse input go into that little square, which corresponds, if you look back on this, to this area right here. So it's actually stopping me from using the mouse to do anything else. If I go into Process Explorer, actually if I go into Process Explorer, which I got here, you can see there's lock screen down here at the bottom. So that's what I launched. It has no description. Here's the company name, which is in Russian, and it's got no digital signature on it. So it's satisfying a whole bunch of those examples of malware, and it's packed, as you can see when I move the selection off it. So very matching all of those characteristics that we talked about. So how do we clean this thing off? Let me get the virtual machine ready. We go into safe mode. And this thing is going to stand out like a sore thumb once we're in safe mode. So take a second. Wait a minute. That's that's safe mode with, sorry, that was safe mode, regular safe mode with networking. I need to do safe mode with command prompt, like I mentioned. So that shows you how this thing is active even when we go into safe mode. We need to go into safe mode with command prompt, and at that point we're going to actually just see a command prompt, and I'll be able to run auto runs. We'll see here in a second. And auto runs. And this thing just stands out like a sore thumb again. It's actually configured itself in two places just to be sure. It's taken over the shell. Remember we saw the shell earlier? So even if I clean the thing from the run key, it's taken over the shell, which is another place that msconfig Task Manager doesn't look. When I log in, it gets activated just because it's my shell. And then what it'll do is launch Explorer, but it's effectively gotten control of the machine. So to clean this off, I simply say check, check, and I'm done. This next case is one where a user sent me just recently. And they've got this big gaming rig under their desk in their home office. And one day the fans in the machine started to get very loud. Now normally they only get loud when they're playing video games, because what drives the fans on to full speed are the GPUs, this big GPUs he's got in it. So he's like, what the heck is going on? The fans are very loud. Something's burning resources on my system. It sounds like more than just CPU, because my fans don't get that loud when I've got CPU intensive stuff. It's probably the GPU. So he opened the ATI control panel applet for his video card and saw that it was reporting 90 to 95% activity. Now the thing with that control applet is it doesn't tell you which process is consuming the CPU, is using the CPU. That's where Process Explorer comes into play. So he fired up Process Explorer. Let me show you how Process Explorer's got GPU capability. I'm going to fire up something called MSI Combustor, which is a GPU burn-in benchmarking test program, and run GPU burn-in benchmark. And one of these system dialogues, one of these system views are up here of resource usage, is you're going to see it start to go up. Would you see which one it is? This one right here, which is telling me that I've got MSI Combustor consuming 100% of one core on the GPU. So not only that, but if I go and select Combustor, where's MSI Combustor? Down here at the bottom. Process Explorer also has a tab here, the GPU graph tab, which will show you the GPU usage, including the memory usage as well as the GPU engine usage up here. You can see that this user, when he was troubleshooting this case, let me go kill this thing because it's burning a lot of, whoops, a lot of resources. When he took a look at that, oh, actually, let me get the next case ready here too, the next VM. But when he was looking at it, he added the GPU columns to the Process Explorer graph. You can see GPU right here, and you can see the process that's consuming 96% of the CPU is something called javasked.exe. Obviously, and it's got no company name, it's got no description, so it's obviously something that's potentially suspicious consuming the CPU or the GPU. What he did is killed the process. At that point, the fan stopped executing, and he went in and investigated the binary. Now, one of the things that I always recommend you do when you run into a suspicious binary is upload it to VirusTotal, which is 40 or 50 antivirus engines that they run the executable against, and will tell you if any of them flag it as malicious and what type of variant of malware it is. VirusTotal said it was a bit count miner. Defender didn't identify it as anything malicious. So this VirusTotal report did confirm that this was Bitcoin. Anybody here mine Bitcoins? Out of curiosity? Raise your hand if you mine Bitcoins, a few of you. So it's gotten really popular for, Bitcoin's this new type of currency that's based on going and doing complex cryptographic operations to generate Bitcoin. So if you've got a high-powered GPU, or even if you've got CPU, you can go and generate Bitcoins, and depending on the value of Bitcoin, it might be more valuable to generate those Bitcoins than actually the power you're consuming or you're burning to do it. And so what malware has done is saying, I'm not going to use my own power to generate Bitcoins. I'm going to use everybody else's power. So this is a new type of botnet kind of scheme we've got going on here, where the malicious, the bad guys, get their malware on your machine and use your GPU to mine Bitcoins for them. And that's what was happening here. The malware was blocking auto runs from running, so he went to the run key just on the hopes that that's where the malware was configured, and sure enough, he ran into it right here in app data. Again, if it's suspicious, a little suspicious that it's in the roaming part of app data, because you're not going to find legitimate software there. It's something called systweak, and he deleted it, and that problem was solved. I've got an example of something called Vicenor, which is another Bitcoin mining piece of malware. Unfortunately, this is running in a VM. This is GPU-based Bitcoin miner, and I don't have GPU support in the VM. So this thing isn't going to really activate fully. We're not going to see it burning the GPU or even using the CPU. A lot of Bitcoin miners now burn the CPU if they can. But what I've done is just activate it, and we see nothing visible, of course, until we open up Process Explorer and take a look at what we see. All the signs that I've mentioned. It's packed, and it's got no company name and no description, just like we've seen. And it's stuck itself, again, in app data local, in temp. Minerd. Where's Minerd? Minerd is the Bitcoin miner. If you uploaded that to VirusTotal, it would say this is the Bitcoin miner. And it came out of this primary executable, which I had just named Vicenor. If you take a look with category as right, which I've got configured here, and we search for Minerd, you'll see Vicenor creating it right here. It creates Minerd, and then it starts writing to it. These are write files. So it's dropping the file on disk. And if we open up Vicenor and take a look at the memory and memory strings, we'll see Minerd stored within it. And the way that we can recognize that is that we'll see its usage. Let's see. Usage strings here for, this is the Minerd usage right there with the parameters. You can pass -O to Minerd. You can pass -X, the proxy. The Bitcoin mining server is -O. And if we take a look at the command line here, you can see the Bitcoin mining server is, well, no offense to the Russians, but it is in Russia, ispilledsoda.ru, which is not an active domain at this point in time, but that's where they'd set up their Bitcoin mining server that this thing would try to go and put money into. This next case is one that Microsoft Consulting Services ran into when a customer reported that one of their systems was talking out, and it was a system that shouldn't have been talking out to the internet. It was a system that was an Exchange server. Now, why was the Exchange server talking out to the internet? Forefront Endpoint Protection had previously detected some malware, but then said it had cleaned it off. The thing was still generating traffic out to the internet. So the Microsoft support person had them capture a process monitor trace. And let's go take a look at that quickly. And see what they saw in the trace. The first thing that they're going to do is open up the process tree to get a lay of the land for what processes are executing on this machine. As the support engineer looked through it, he noticed, hey, wait a minute, there's a whole bunch of FTPs. What are these FTPs doing? He takes a look at the command line for FTP, and he sees that FTPs doing in this non-interactive mode going to go and execute the commands, the FTP commands that are in a file called J. So he wanted to get his hands on J to see what this is doing. Maybe, is this thing suspicious? Is this malicious, or is this some part of some legitimate software? What's going on? So he set a filter just for FTP, and he searched for /J to see where this thing was. He saw it was sitting here in this directory, but he went and looked, and he couldn't find J. It wasn't there. So what was in J? To get an idea of what was in J, potentially, he looked at the parent process that launched that FTP. And you can see a big, long command line. Let's decrypt that command line by putting it into Notepad. And here it is. And there's a lot of ands because this is one big command line with a whole bunch of subcommands. And what I'm going to do is search for and just replace it with return. And then now you see what it's doing. It's opening this FTP server right here. It's entering a username and a password. It's getting all the executables off that. And then it's creating a batch file, which is just going to go launch all those executables. So this is just a generic, let me pull whatever crap down from my command and control server onto this machine and just launch it. You know, I didn't even bother doing this until yesterday. But yesterday night, I'm like, hey, I wonder if what happens if I do FTP there. Oh, look. Does new work? Does 1, 2, 3 work? I'm in. Now, I don't know if it's illegal for me to do anything at this point in time, so we're not going to do anything. But feel free to go take a look at what's going on there. So next question is, okay, who's the parent process for this thing? And if you go up, this is the scary thing. Where's the parent process? SQL Server. Uh-oh. What's SQL Server doing launching command prompts that are launching FTP commands? So what he did at this point was set up an include filter for just SQL Server. Let me get rid of the FTP one. And then he looked for network activity, outbound, because remember this thing was outbound. And here's one to a strange IP address. It's not even DNS based. Now, the next thing he did is like, where the heck are these IP addresses that aren't domain names? So let me copy that, paste it into Notepad. And let's go see where this thing is. Anybody have any guesses? Russia. This is an IP tracker website, and it is in close. In fact, you can, we can go take a look at exactly the building that it's in by zooming in. So, all right, at this point, he said, maybe this thing is malicious, maybe. And what he did at that point was ran a standard tool that support services has that just looks at the SQL configuration. And sure enough, this thing had been configured with no password and XP command shell configured. So this means that whoever set up the SQL server left it just wide open. It's sitting on the internet. Anybody can hit it, no authentication, and launch command shells on it. And so what probably got to happen is this is some random, botnet thing that's scanning the system looking for open SQL ports like this to see if it can get in and happen to get in here. Probably not specifically targeted at this company, but just happened to get caught. And when the support person notified the customer, they said, they took a look at it. Well, look, that Exchange server is not supposed to have SQL Server on it. They figured some admin had temporarily installed it for some reason, didn't realize that this machine was on the internet, left it wide open. Everybody forgot about it, and now it was a problem that they had on their hands. So in this case, Microsoft Support Services, who knows what kind of crap went into that machine and then went out trolling across the network. So at this point, they recommended flatten the machine rather than try to fix it, and the case was closed. I've got one more example here to talk about as we wrap things up, and this is getting more into the more sophisticated side of things. And I'm going to get this VM ready and going. How many people have heard of Flame, a piece of malware called Flame? So some of you have, a lot of you haven't. How many people have heard of Stuxnet? So almost everybody's heard of Stuxnet. Stuxnet, of course, one of the most notorious pieces of malware ever. Some people will say that it's not malware. People call it also a cyber weapon. Maybe some people call it a weapon of good. But Stuxnet was a piece of malware that was discovered in July of 2010. Let me get my VM up. Where's my VM? Hello. VM, where'd you go? Oh, it's still starting up. Okay. While this is waiting, while I'm talking about Stuxnet and Flame, I'm going to launch Flame in this VM because it takes a few minutes to activate. And this is a little setup for the story. One of the things that I had to do to get it so that I could even activate Flame is to set the time zone to this place. Flame does not activate if the time zone is not Tehran. It also does not activate if I've got Process Explorer running. So I can't have Process Explorer running while Flame is active. The way that we're going to know that, I didn't mean to hit Windows Media Player, but the way that we're going to know that Flame has infected the machine is that you're going to see ccalc. Look right into here. Right in between here, something called ccalc.sys is going to show up, and that will tell us that Flame has fully infected this machine. So that's going to take a few minutes. And while coming to that, let me talk a little bit about Flame and Stuxnet. Because Stuxnet and Flame are believed to be part of the same cyber espionage, cyber warfare campaign, believed to have been started under the Bush administration, continued by Obama, with collaboration of Israel to attack the nuclear weapons development system of alleged nuclear weapon development program of Iran. You can see that the Stuxnet made its way into the Natanz nuclear enrichment facility in Iran. Was incredibly sophisticated because it had 4 Windows 0 days, 2 to spread remotely, 2 to gain admin privileges on systems where it came in as a standard user. It had a rootkit that infected the Siemens Step 7 programmable logical controllers, the same ones used to control these centrifuges in Iran, caused them to spin at variable rates and burn out, and obviously produce bad enriched uranium. You can see this is former President Ahmed, touring the Natanz nuclear facility and saying, yeah, this thing has destroyed a couple thousand of our centrifuges. after they probably executed a bunch of nuclear scientists for not figuring out what the heck is going on with the centrifuges. Now, Flame was discovered about a year ago, and Flame was, some people, like Kaspersky, says, oh, no, this is the most sophisticated piece of malware ever. Why does he say that? This thing is the largest piece of malware ever. It's 20 megabytes in size. It has multiple configurable modules, ones that will go sniff Bluetooth, ones that will turn on the video camera on the PC and record, ones that will turn on the microphone, ones that will log keystrokes. It's basically an all-in-one spy engine. And the way that it's spread is by taking advantage of an MD5 hash collision on the terminal server licenses that customers create when they license terminal server systems in a way that allowed it to spoof Windows Update so that it could spread using Windows Update inside of corporate networks onto PCs. So obviously heavy-duty crypto and deep knowledge of the way Windows works behind Flame, not to mention the sophistication of all these components. Breaking news on this whole story is that just yesterday, take a look, here's a story that leaked last year, or that came out last year. Well, this actually came out, this is Flame, May 29th last year. Iran says that we were attacked by something that's spying on us. Here you can see the New York Times story last year in June that somebody leaked, that somebody in the Obama administration said this is a program called Olympic Games, started under Bush, continued by Obama, collaboration with Israel to go attack these nuclear programs. But they never had a name. They never revealed a name. So it was always like, well, somebody says, the New York Times says, somebody says that this is a new U.S. program. As of yesterday, now this guy is under investigation. Retired Marine General James Haas Cartwright, second highest ranking member of the U.S. military, key Obama advisor, that he was the one that leaked, and now he's under investigation. That the U.S. government's accusing him of leaking that information. So that was a breaking just yesterday. Now let's go back and take a look at Flame and see what it does. And so is our CC calc. There it is. Let's take a look at Process Explorer now. Now that it's active, we can launch it safely. And actually, Flame does not appear anywhere in the process list because what it's done is jump into a process and infect it. Which process has it jumped into? We can tell that because I've got process monitor with category is right. So while Flame was infecting the machine, I can see what it was doing. And as I scroll down through here, we see a lot of writes coming from the Service Control Manager. And they're writes to this file right here. In Common Files, Microsoft Shared, MS Security, mscrypt.dat. This is actually a SQL Express database. So not only is Flame all that components, but it's written in Lua, the Lua scripting language, and it uses SQL to store its configuration. So it's a pretty sophisticated piece of malware. I've never seen a malware author say, oh, let me store how should I store my configuration? Oh, SQL. Let me install SQL on the machine, and I'll store my configuration there. But that's what Flame does. And the way Flame activates is it also infects a place that's never seen by any of the standard auto start locations. Here you can see when I ran it, reg set value, HKey local machine, authentication packages, and this is where it's sticking in the reg multi-SC its primary payload, which is mssecmanager.ocx, which it also dropped onto the machine. So it's loading itself into the LSA process. You can see it's infected services. When the system boots, it launches in as part of LSA-SS, so it's not going to show up inside of Process Explorer, Task Manager, or anything else. You'll have to know it's there by the symptoms, and then you would be able to see it by looking at what these malicious activity coming out of these processes. So that's a quick look at Flame. Now that brings me to the end of the talk. I've gone a few minutes over. I just want to wrap it up with a couple things. One is just a view of kind of the spectrum of malware that we see these days, all the way from the junk. You've seen a bunch of junk. It just satisfies all the criteria, all the way to something as sophisticated as Flame, and everything in between. The fact is that malware authors only do the bare minimum. They only do what they need to do. They're just want to minimize their investment, and unfortunately you can see by how much junk is out there that it can be pretty effective by not doing much, not putting in company names and descriptions, basically sitting out there and wide open to tools like Process Monitor and Process Explorer and auto runs, but it's okay because they get their job done and are making money for these guys, or whatever aims they're after. But then you see the other end of the spectrum, which is getting very, very sophisticated, types of malware that are almost impossible to spot unless you know exactly what to look for. The primary message of this is try to prevent the malware from getting on your systems and put in a lot of detection, a lot of monitoring to hopefully detect when you get malware on your networks. And then finally, some of you probably know that I've written cybercrime novels, a couple of them, Zero Day and Trojan Horse. I want to very just quickly show you a video trailer for Trojan Horse. It's the second one, and it's, do I have? It took me forever to make my voice sound that cheesy, but I finally managed to do it. I don't know if you caught it, but Kevin Mitnick wrote the foreword for that, and I didn't realize this until I read his foreword, which says, "I can't believe Mark Russinovich tricked me into opening a document called Trojan Horse." But so that was a pretty proud moment of my life. Anyway, thank you very much for coming. I hope you found something useful. Hope you're malware free. And I'm going to be moving over to four.
No, you're not.
Oh, I'm not moving anywhere, so you can sit in your seats if you're here for Casey Then Explained, or take a bio break or whatever, and I'll see you, right? I'm assuming I'm here?
Yes, please, but they need to take their bags with them if they're going out for coffee.
Okay.
They can't save seats.
Or you can leave them with me if you'd like.
So you'll get 700
Okay.
bags.
All right, so hope to see you in the next session. Thanks.